So now we're going to talk about something that's kind of technical but really important, and it's variable scope. So we have variables, and variables have names. Like a is a good name for a variable. And then later on in the program, the whole point of variables is that if we refer to that variable, then we get its value. So its value is kind of persistent. Um, but um, Sometimes we use the same symbol in two different contexts, and even though the symbol is the same, the value is not the same. You might have some kind of inner block here. It's a little bit unnatural because I've created a new block here without any while or any statement like that, but still perfectly fine. So I can declare a new variable, which is also called a, inside this inner scope, and it actually has its own value. Okay, so that's not surprising because um, it looks like maybe I just overwrote the value of the original a and made it 3, but you can see back here in the outer block it's still 5, so that hasn't changed. What's happened is there are two different variables here that have two different addresses, and you can look and see what their addresses are if you want to. So the address of the inner one is sorry, that, and the address of the outer one is that, and they will be different. So you can see they come right after each other on the stack, but still they're different. Um, on the other hand, if you get rid of this inner declaration, the inner scope inherits what A was in the outer scope. Now the addresses are the same, and the values are the same. So it's really the same variable there. So that might come up naturally in a context like a for loop or something. Something similar happens with functions. So let's say you have a function up here called incrementor or something, and you want it to increment a. And let's take a look at the address of a up here. And here we'll have good old regular a equals 8 down here, and that's its address, and that's its value. So we'll say that's the main a, and here's the func a. And let's take a look. And somebody needs, what's wrong here? Oh, it's because I never called the function, sorry. And so here I'll call the function. Alright, so the variable a in main has this address. The variable a in the function has a different address. The function, when you pass it a parameter, it makes a local copy. It doesn't use the same value that came from main. It makes a different a, and so if you change a up here, it doesn't affect a down here. You can see at the end, a starts out as 8, and then even though you go to the incrementer function, it's still 8 at the end. On the other hand, this one up here is going to have the value 9 because the value of the current a does get passed in. So this 9 here comes from this line. So that's the value of a in the function. But because this a in the function lives at a different address, when it goes out of scope here, it just stops existing. That's because the stack pointer pops down, and it essentially erases that memory when the function returns. So what if you do want it to be the same up here as down here? You can do that, but you have to use pointers. So instead of passing an int, you need to pass an int pointer. And then instead of incrementing the pointer, you want to increment what the pointer points to. And so let's get rid of all this stuff and try to make it simple here. So here we'll just print out the value of a, so that's fine. And we'll pass in the address of a instead of passing in a, and let's see what happens. Right, so it was 8 here. Now because you passed its address up to the function, the changes that happened up here affect this, and that's because you're talking about bytes that are in the same memory locations, the same variable. And so that's how you, this is called passing by reference instead of passing a copy. And it can also be useful when you have a big parameter to pass, something that takes up a lot of memory like a struct, but we haven't talked about structs yet. Alright, so that's how memory scope works. There are a couple of exceptions, static and global variables. So let's see if I can give let's give an example first of a static variable. And so let's create a function called num_otters, and let's say it takes no inputs, but it has a static int num, which is 0, and then it does num++, and then it prints out the value of num. New otter, num equals blah, and here we'll write num, and down here in main we'll call num otters a few times. 1, 2, 3, and we'll see what happens. Okay, so notice that each time I call it, the number of otters goes up. That's kind of cool, isn't it? And here I assign it to be equal to 0, but that initialization only is operative the first time I call the function, and then all the subsequent times it ignores this assignment and it's just the previous value. So it sort of remembers what it was before, and that can be useful in situations like this, where you want to keep track of the number of some objects or something like that. If you take the static qualifier away, then it gets forgetful and it says num1 every time. So it's the keyword static that makes it remember. So even though this is a static int, that doesn't mean that it has a value down here. So this will give me a syntax error because down in the scope of main, it has never seen that identifier num. It doesn't know what it is. Okay. So let's talk about, can I pretend like I'm Canadian? Let's talk about, it's time to talk about global variables. So global variables are defined outside of any function block. If I declare something up here, int global 1 equals 99, then I can talk about global 1 down here, maybe g1, global 1, fine. Alright, so here let's print out the value of global 1. That's right, buddy, global 1. And it's going to be 99 in main, just like it was in, just like it was initialized to be up there. But let's say that I call this function foo, and in the function foo, what happens is that global 1 gets incremented. So will that affect the value of global 1 back in main? And the answer is yes, it will, and that's because there's just one global 1. So it's a global variable. You can, if you change it anywhere, then there's only one copy of it. So if I were to check the memory address here, it would be the same as the memory address here. There's only one copy of the variable, so it doesn't matter where you change it. The change is effective everywhere. And this can be kind of a lazy way to pass variables to functions, but because then you don't have to put, let's say there are a bunch of variables of interest, int a equals 1, b equals 2, c equals 3, and here in foo what I want to do is a equals b equals c equals 99, and down here in main I want to print out the values of all those things. And so here I write A, B, C. So if I do this now, then they'll be equal to 1, 2, 4, right? 1, 2, 4. But then if I call foo, they will all be equal to 99. So it's kind of like I managed to return a bunch of values. And it seems like a good thing, but it can turn your code into spaghetti if you abuse it. So sometimes global variables are good, but try to use them kind of sparingly. And that's all that it occurs to me to say right now. Yep, that's it. Okay, see you later.